Hello students, now we are solving the problem of stepped bar. Problem definition is like this. As per the given sketch, there are two steps in that given bar with different Young's modulus values. So first step we can see E value is 2 into 10 raised to 5 and area is 900 mm square and its length is 600 mm. And second step is E value is zero point 0.7 into 10 raised to 5 and area value is 600 mm square. Its length is 500 mm and Poisson's ratio is given as 0.3. For clear understanding of this problem, we have drawn ray diagram indicating three different nodes. We have to be careful here because node 1, node 2 and node 3. Node 1 and node 2 makes element number 1 that is of different cross section and node 2 and node 3 makes a second different cross section with different E value. So we have already solutions that D1, that means displacement at node 1 is 0, displacement at node 2 we will get this value and displacement at node 3 is this value. We have to check it later. And reaction force when we solve by FEM method we are getting nearest to 500, that is minus 498, and stress at element 1, that means first element is 0.533 and element 2 is 0.817. Let's solve this problem by ANSYS. So we are using ANSYS 2022 R1 version, that is. So first you go for preferences, structural, click OK, then go for preprocessor, element type, add, edit or delete. Here add option, select link 3D finite STN180, click OK. Close this menu. Next come to material properties. So material models. So here there are two materials. As I told in this sketch, two different E values. That's why we have two materials. First material model number one, structural, linear, elastic, isotropic. Here the enter the values related to the first part. E value is 2 into 10 raised to 5. So I am entering here 2E5. Then Poisson's ratio value is same as per the given problem, that is 0.3. Click OK. Here for another material, you have to click on material, then new model. So it will show you define material ID 2. Let it be as it is. Click OK. So then once again go for the structural, linear, elastic, and isotropic steps. Click on isotropic, then enter the second E value, that is 0.7 as per the given problem. 0.7 E5, then same Poisson's ratio value 0.3. Click OK. So here you should be very careful as it is a stepped bar with two E values. That means different Young's modulus values. So here now you close this one, then go for sections. Once again go for link, add. So here you have to give link ID 1, click OK. Section name you gave 1 and link area. Area of the first section, that is 900 mm square. Enter the value here 900. Then click apply. Then go to second, give the number 2, then click OK. Section name 2 you enter, then link area, that is second area, that is A is equal to 600. Enter the value here 600, then click on OK. Carefully have to enter both the areas, then come to modeling, create nodes in active CS. Carefully observe node number 1 always starts with 0 because that is starting point. Click apply once, then enter node number 2. So distance, look at the given problem. Node number 2 is here, that is at a distance of 600 from node number 1. So enter the value here 600, press apply once, then enter node number 3. So in the problem, node number 3 is here. That means 600 plus 500. Total value you have to take 600 plus 500. You can directly enter or you can press plus 500, then click OK. On screen, it will appear as number 1, number 2, and number 3. Now, three nodes are created. Carefully, you have to create the elements. As there is two different cross sections, I am going to elements. So, before entering the elements, we have to check element attributes to ensure first is material number 1 and section number is 1. Click OK. Go to auto number, through nodes, select node 1, node 2. Don't select node 3 because it is separate cross section. Click OK. First line will appear. Then once again go to element attributes. Change the material number to 2. Same section number to 2. Click OK. Again go to through nodes. Then select node number 2 and node number 3. Click OK. The second line will be generated. Now you go for applying loads. Go to loads, define load, apply structural. As first point in the given problem, this node number 1 is fixed. We have to apply displacement on node. Click on node number 1, go to apply. All degrees of freedom should be locked. Okay. A small two triangles will appear that will ensure you the degrees of freedom are arrested. Then come to the force bar movement on node. There is no load at 2. You click at node number 3. Then go to apply in X direction. Apply the load 500 Newton as per the given problem. Okay. A small red line will indicate. If you scroll down, the line will appear clearly. The middle line will disappear. No need to worry. Then go for solution. Solve current LS. OK. So the solution is done will appear. This ensures you all the steps are taken perfectly correct. Then close this one. We have to go for the results. So before going for the results, we have to go general post processing steps. Here we can list the result and plot the results. As this problem is different from the single bar or the bar with the same cross section, we have to go for element table, define table, then add here by sequence number ls, then enter value 1, click OK. But sometimes you will get error message, or here you can see after entering also you will look at this one none defined. So to avoid this problem, just close this one. See, the requested database is not available, like this error message you will get. No need to worry, close this one. In command prompt, you enter set comma last last, type set comma last and press enter key. Again follow the same step, element table, define table, add. So here by sequence number, enter ls, here number 1, then click OK. So now clearly observe the table is defined. Then close this one. Coming to the list results. So in list results, we have to list first nodal solution, DOX solution, X component displacement. Click OK. So we will get the three displacement. At node 1, it is 0. At node 2, 0.166 into 10 raised to minus 2. At node 3, 0.76 into 10 raised to minus 3. Already we have got the value in 10 raised to minus 3, but the values are almost near and same. So then go for keep this one side, then go for element solution, stress value, X component, OK. As there is a two-stepped bars, there is a two stress. So first in first bar step is 0.556, and in second one is 0.833. So as per our analytical solution also matches the value, that is 0.533 and 0.817 values are nearest. Last one, reaction solution, all items okay. Reaction force is always same as the magnitude is same as the applied load with negative sign. Yes, it is minus 500. So you can save these values for the further reference. Otherwise, close this menu. So to plot the result on screen, we have to go for plot results. In that one, contour plot. So directly we can go for element solution or nodal solution, DOF solution, X component, okay. So here the DOF solution or deformation will be visible on screen. Similarly, element solution, stress, X component, okay. Stress value will appear. This is once again the value of deformation. You go to element table, LS, click OK. Here you will get both the stress values. For 3D view of the part, you can just go for plot control. In that one, you must change the style, size and shape. You go for display of the element on, OK. Then you select the isometric display. So here, plot control, animate, deformed results. So click on OK. You will get the results with deformed shape with colorful rendering of this one. Thanks for watching.